Everyone, so today we are solving another interesting problem, number 154. Find minimum in a rotated sorted array 2. And we have been given an array of length n, sorted in ascending order, is rotated between 1 and n times, and it has been rotated at some point in between, and we want to return the minimum of this array element, and it is said we want to decrease the overall operation as many steps as possible. So one thing that what we can do immediately is we can directly return false. So we can directly return minimum. So what we can do is we can directly do return minimum of nums. So that would give me the minimum of the whole array in just one step, and the time complexity for this is O of n, because we are traversing the whole array and we are looking up in the whole array as we are traversing in the array. So but the question is, can we do better than this? Better, yes, and the answer is yes, we can do better. And what we can apply is, since the array is sorted, we can apply binary search to our rescue to solve this problem. And here is how we can apply binary search. So we have the array in the form of sorted. So we have the array something like this. So if I model indexes over here and the nums, which is my function value over here, and if I plot these, then what we will get is, I'm plotting it for let's say we have something array like this. We have 3, 4, 5 and 0, 1, 2. In this case the output we want to return is 0, because that is the minimum value. So we'll plot this into our graph. So what we can see is this graph would look like this. So at some point it has been cut, and then we are going again increasing. So, and this is the pivot index, you could say, where the value has been, where the array has been rotated, and it has been rotated and we have been given to it, and we want to find the minimum value where we see this I would say discontinuity. So what we'll do is we'll start with the left and right pointer. So we'll place two pointers, one to the left, another to the right, and as we are going we'll compare. We'll first find the mid would be somewhere here at L plus R by 2, and then we'll check like from which region we want to move. So here we are looking that the function value is f of r and the mid value is f of mid, and when f of mid is, in this case we are looking for minimum, so we'll look from right. So if the mid value is greater than the right, then we'll update our, so this, you see this is mid value and this is my r value, and I'm definite that the minimum would lie in the right region here. So I will discard this region of mine. So I'll update the left pointer toward the mid. So I'll bring my L is equals towards mid plus 1. Otherwise, if the mid is lower than the right, then I will update my right pointer, because again this L would come over here. So in that case we want to calculate new mid, that we'll get by finding the new mid from this region. So now our mid will be shifted over somewhere over here, so we know the mid is in the left region. So we'll calculate again the mid values and the check it with the right value. So in this case the mid is less than the right, so we want to update our right pointers toward the mid. So this will come over here. So this would be the approach, and this we'll do until we have exhausted both the left and right pointers, until the two meet together. So now let's get into the coding part of this so that we can start writing the solution. So the solution would look like this. So the very first thing, we need two pointers left and right at 0 and n-1. Here n is the length of the nums list we have been given, and we'll exhaust until both left and right meet together. So first we need to calculate mid. So mid is left plus right divided by 2. Now we'll check. So we have been given the condition that there could be duplicates. So if we find that our function value is equals to nums of mid value, nums of right value, then we will just decrement, we'll skip that value basically. Otherwise we'll compare, else if the nums of mid is greater than the nums of r, so we know we need to update our left pointer in this case. Otherwise we need to update our right pointer toward the mid. And in the end we know that the left would be our function has reached to the minimum value in the left pointer, and we want to, this time we want to return the value, so we'll do return the value rather than the index. And the time complexity for this approach is O of log of n, because we are dividing the search space in half every time, and the space complexity is O of 1. So now let's run our solution and see how it performs. So now let's run it. So it has been accepted for 135, and we'll write for our own test case. Our case was 3, 4, 5, 0, 1 and 2. So it has also been accepted. Now let's run for different edge cases where we have duplicates. So that has also been accepted, and now let's submit our solution and see how it performs. So it has been accepted very well. So yep, so that's how it's been, that's how you do this problem.